Hey, what's going on? Welcome to another episode of Angular Air. I'm your host, Justin Schwartzenberger. And on today's episode, we are going to do I don't know, maybe some crime scene investigation. I don't know, turn it into a true crime stream. I don't know. We'll see. But we're going to do some forensics and things like that. It's going to be super interesting. We got a returning guest. We're excited about that. First, let's say hi to our other host, Mike. What's going on, Mike?
I've been promoted from panelist to host. Nice.
We're all hosts. We're all hosts.
I like it. I'm happy to be here.
Yes. There you go. Awesome. I see we all both have our new spectacles on. I don't know if you want me to bring it up. I'm bringing it up because I'm wearing mine. So
I thought it was the old age club's initiation gift.
It's like a card, right? It's like a member card or the old age member card. I don't know.
Yeah.
Nice. And our guest joining us once again is Manfred. Manfred, how's it going?
Yeah, fine. Thanks for having me.
Awesome. Been a guest many times, so we're always excited to have you back. Love learning from you and seeing what you got going on.
Yeah, I have told you before, I really like this format because it's a bit different. It's not just a presentation, it's about chatting with you guys and so on. And yeah, it's really cool.
Nice. Yeah, we love to ask questions and dive in a little deeper and stuff like that. So yeah, it'll be great. What are we talking about today?
Yeah, it's really about your code as a crime scene. And I have some slides to motivate what this is about and why it's called that way.
I'm just really hoping this isn't my code base that we're looking at.
Sweet.
So if you want, you can put my screen to the screen and then we can get started.
Sounds good. Let's do it.
Awesome. Yeah, so all of this is about improving your architecture with so-called forensic analysis. And I want to show you what this is all about and how it can help you. And I want to get started with one thing we are doing on a regular basis. Besides doing training and consulting, we do architectural reviews and code reviews on a regular basis. Actually, most of the time, it's a combination of both. And we have there, meanwhile, a process. We do a code review, which means we look at your source code, of course. But something I really like to do more is to do a joint walkthrough with developers, because then I can directly ask questions, there can be a discussion and so on. And this allows us to bring our knowledge together. Of course, it's also about developer interviews. However, this sounds that formal. At the end of the day, it's about asking good questions. And I think a consultant should really do this. His or her primary task is to ask good questions that start a thinking process. And perhaps the answer is, yeah, you're right, let's go into this direction, or no, you're not right, we are fine here, let's go on with the next topic. And when doing all of this, we have two things in mind. By the way, I use the term developer interview here, but it could also be more general as stakeholder interview. I remember this situation where this company had a project. It really worked well within the company, but they wanted to make a product out of it so that they can adopt it for other companies. And in this case, we needed also to talk with product managers. But normally we talk with developers. And when doing all of this, we have two things in mind. You could say we are evaluating everything we are seeing and hearing against two topics, two fields. The first field is your architectural goals. Of course, for this, we need to talk about it upfront. And the second field is best practices established in the community, because swimming across the stream is a bit annoying if you do it on a regular basis. And the result of all of this is consequences and trade-offs we are pointing out. So I think you should really be aware of the consequences. You always have consequences and trade-offs, but this is about having them in a deliberate way. We want to have deliberate consequences, and it's obviously about recommendations for improving your architecture and your code. And I'm very sorry, there is this little white space here. My monk within was telling me you need to fill it up, but I had no idea what to put there because I didn't want to lie or to invent something. So yeah, my inner monk has to live with it, I guess. This is our process. So, and this is also the beginning of the story. But the story goes on. It goes on with the spring. Here we see not the Rocky Horror Picture Show, but me and my colleagues, Michael Eckert-Sickers in the middle, and Rainer Hanekamp, who is also a GDE for Angular on the right. And together we visited NG Belgrade this spring. And it was really an awesome conference, well organized, really cool dogs. And in the evening, we went for dinner. We went down this nice river. It was about 1 kilometer to the restaurant. And there, one question came up. We discussing code. We started discussing code metrics. And one question was, can we support our reviews with code metrics? And here I had a very elaborated answer, and this answer was no. So my gut feeling was no, because I don't believe that much in metrics. I know about them, I played around with them, I taught them, but I had the impression that a metric cannot mirror the complexity of what's considered quality or good code, good architecture in a real world code base. This was my intuition. And there is a nice example that shows where my intuition comes from. So here I have two code examples, a left one and a right one. So Brocchi and Swati, what do you think? Which of those code fragments is more complex?
I'll go in with the right.
Yeah. So I think our gut is telling us the right one is more complex, right? And yeah.
Yes, from human readable, it kind of like I kind of guess right away on the left what it's about, and on the right, I have to kind of read more and focus more to really kind of think about what's going on, right? At least from a first glance.
Totally. You need to wrap your brain around it and so on. So it takes more cognitive load, I guess, which is an important concept when it comes to code complexity and also quality, as we will see in some minutes. But funnily, both examples have the same complexity if you measure it with this good old cyclomatic complexity, which is quite a well-known measure, a well-known metric. It's implemented in all those tools that perform static analysis on your source code. And I really think that this is one of those examples that really show why I don't have a good gut feeling with all those code metrics. Or metrics, I don't know, you know what I mean.
Because this is saying that like looks like there's like 4 kind of decision points, right? Or logical points. And on the left and the right, they both have kind of like 4. So you're giving it a score. It's giving it a score of 4 on each side, which seems like they're equal. Yeah.
So for each branch, you have +1. Every time you have another path that goes through this piece of code, you have +1.
Yeah, it's interesting for Justin and I to look at this, because years back, he and I gave a talk together about the illities of code, of different aspects of development, and complexity was one of them. And the other big one that we tried to focus on there is readability and understandability, maintainability. And this kind of adds to that, and seeing the ITY up there in complexity kind of brings that all together of these are the things you need to think about when you're looking at code. I know you're driving home the point of they are the same score, but the readability and the understandability is a little bit low on the code on the right.
Yeah, completely. And it does not necessarily correlate with each other. Readability, understandability, and complexity, right?
Mm-hmm.
And I also made this experience in other projects where the customer forced us into applying metrics and into reaching some goals. And there is another reason why I was a bit skeptical in the beginning. It's Goodhart's law. I didn't know that it's called Goodhart's law before, but I knew the saying, and I guess you also know it. When a measure becomes a target, it ceases to be a good measure. Think about code coverage. I really like to use this example because this Goodhart's law was already discussed in the test-driven design community, test-driven development community years ago, decades ago, when it started to become a thing back then. And there, a lot of experts like Fowler or Kent Beck are saying that it's not a good idea to define code coverage as a goal, as a target. They say, look at it from the other way around. The code coverage tells you where some improvement might be needed. It might give you an idea where you could do a bit better in terms of testing, but it's not a goal. Because as soon as it starts to be a goal, people adopt to it. They want to reach this goal, and that means they perhaps write test cases that come with a lot of coverage, but that are not that meaningful. And yeah, I think this is true for a lot of other metrics we have in the community. Have you heard about this law before?
I have not, but as soon as you mentioned it and talked about it, my mind immediately went to the code coverage thing. That a lot of companies tried to use that as a metric, and immediately people tried to game the system to say, hey, I'm going to try and get around that by not having to write good tests. And I'm wondering if there's a disconnect because of a management target as a way of measuring is a sign of not fully understanding or being able to make the efforts to be able to do the measuring themselves with an eye test or something, to your point of not being able to add specific metrics to a system as a way of doing the evaluation for an architectural review.
Yeah, I completely feel you. By the way, the person here on this picture is not a person from a stock photo. It's really the guy who defines this so-called law. It's more of an observation, Mr. Goodhart. It's really a nice picture, I guess. It's borrowed from his Wikipedia page. So then we moved on with this discussion. You know, there was a kilometer to go, and we had to go up and down, up a bridge and then downwards. And then I came up with another perspective. I said, well, more or less, perhaps there are some metrics I'm interested into, especially when I'm looking at code from an architectural perspective. And those metrics are all about, let's call it verticals, which is a very generic name. Could be a module, a micro front end, a domain in terms of domain-driven design, strategic design. And what you usually want to have is you want to minimize dependencies between those modules, verticals, as you call them. But within the verticals, stuff is a bit more connected because this stuff has a reason why it's there. It needs to play together and interact to reach a given goal. And there is another law, Conway's law, which says that your architecture, the structure of your system, is always a mirror of the structure of your organization. And yeah, this sounds a bit theoretical, but there is a very catchy way to explain it. It's like if we have 3 teams and if they work together on a compiler, you will end up with a compiler compiling in 3 phases, because somehow they need to distribute the tasks, and usually you talk more to your own people than to people of other teams, and so you will get more or less 3 phases there. And this is something usually nowadays we want to respect when architecting an application. This is what the whole movement around microservices and micro front ends is about. But we can also apply it to a monolithic system if we modularize it into verticals. So this is something you also want to have. Now, if we look at this from a matrix perspective, we have different names. Namely, here we have something like low coupling. We want to have low coupling between the verticals. And here we have something like high cohesion. At least this is what we are aiming for, a high cohesion. And also cohesion is a fancy term, but at the end of the day, coupling and cohesion are 2 sides of the same coin. Here we want to have very few connections. And here we want to have more connections, because we have a common goal in there and stuff in there needs to interplay, or to put it another way, we have a single responsibility. Of course, when we talk about verticals architecture, this responsibility is a bit more coarse-grained, like doing DEXs or working with invoices. It's more coarse-grained than on the class or function level, but still it's one responsibility. That means if you have a system that does your DEXs, purchases milk at your store, and runs your local atomic power plant, then perhaps this system is doing too much. Then you don't want a high cohesion there. And when talking about metrics, well, we can introduce metrics if we want. We just need to count all the connections here and divide it by all theoretically possible connections. And we can do the same here, counting connections and dividing them by all the theoretically possible connections. And hopefully the percentage we are getting is higher here than there. So yeah, if you don't want to do this in a visual way, you can go with metrics. However, there is another metric. But by the way, most changes should be local to one vertically. And this also reduces cognitive loads, because we don't need to have the whole system in mind. We can concentrate on one part, and this means we do less errors, and it's less difficult to get stuff done, we are faster, and so on. However, there is another metric that's come up in this discussion. It's code churn. And honestly, I have not heard that much about it. It pops up time and again, but there is some scientific evidence. There are several studies, not just one, several studies that show that code churn is really a thing for indicating possible issues, for pointing to parts in your source code that might have a lot of bugs in the future, or where you might discover a lot of bugs in the future. And basically code churn is about code that is changing quite often in a short time frame. So let's say within 6 weeks, the same file was changed twice a day. This is an indicator that something is wrong there. Perhaps we have a file with too many responsibilities, which works against everything we had on the slides before, like cohesion and coupling and cognitive load. Or perhaps we don't know about the requirements, so we stumble across them little by little and try to squeeze them in. Something is wrong there if you have a high code churn. Of course, you have to define what's high, so you have to look at the number and evaluate them.
This suddenly became my favorite. I'm really interested in this. Like, this makes a lot of sense of saying monitor these files, how often are they changing? Like, did you plan your architecture in a way that like you've written a file that does some stuff and now it's all good to go, right? And you partition it out. And if your file has high velocity of change over a short period of time, it probably means that you could partition it further, right?
Yeah, totally.
In my mind, being a tooling person, do you have any tooling that helps you with looking at files? So you're brought into a new system and you're looking at it. How do you determine which files to look at for high code churn? Do you have any tooling that would like evaluate a system or a set of files against a version control to say, hey, how frequently are you changing?
Yeah. I have one open source tool I wrote in the last weeks during my summer break. Everyone needs a hobby. But there is a better commercial one. So see my tool as an appetizer for the commercial one. And we will look into them in some minutes. But yeah, you need tooling support. You cannot do this by hand. Finally, I looked up the term churn. I used it all the time. And what comes in mind when I think about churn is this here. But I think the original meaning of churn is producing butter or something like this. Do you know more about this as a native speaker?
Yeah, like churning butter, right? But then it's also used a lot in like customer retention, right? And business and churn. So your loss of customer, how many customers you're losing, and your turnover, and like your numbers. If you have a software as a service and you have subscriptions and you're losing subscriptions, you have that churn to refer to that in a business realm of that customer changing numbers and stuff like that. Yeah.
Awesome.
But I think it's
Yeah,
originally
what came in mind, but I was quite surprised when I was searching for stock photos for churn, and then a lot of farmers
butter.
showed up with butter and milk.
Yeah. Yep. That's how I know it from the like original, is that's what that's referring to. And I guess like I haven't looked in that process, but I guess there's some like replacement or something that goes like that. How do we get to using churn for like customer retention and churn for code changes and stuff? But yeah.
Cool. Okay, so, and this all leads to what's also the title of this whole presentation, to a book that was released several years ago, but there was a second edition this spring. So they updated this book from before the pandemic. They updated it now, and it has been written by Adam Thornhill, who invented this new discipline of metrics. And he is also using code churn a lot. So looking at code churn, looking at your Git history is something he is doing a lot. And funnily, he comes from two directions. He has a computer science education, but also an education in the area of psychology. And he is really into forensics, like, crime forensics, crime profiling, and movement profiling, and so on. And he brings both disciplines together, and that's why he calls his book Your Code as a Crime Scene. Basically, what he is saying, with a lot of cool metaphors around Jack the Ripper and so on, that if you investigate a murderer, then you don't look at the current state. The current state is there is a dead body, but you also look at what happened around it. Who is a suspect and where have they been? What is their movement? What is their typical routine, and so on. And he is using this metaphor for these so-called forensic techniques. And basically, he is also just combining source code with historic data from the Git history, and then he unveils or reveals some hidden patterns. And this is really an eye-opener. Also, if you have written the code by yourself, it's really fascinating to look at your own code through those classes. You will find a lot of new insights there, where you say, yeah, he's right. I would not have thought about it, but this is right. I have to think about this point of my implementation. Yeah, and this is the main point of my agenda for today. Ideas behind forensic analysis. I will tell you about tools for forensic analysis and limitations, of course, because no silver bullets here. And we have a demonstration. Okay, so perhaps some words about me. I'm Manfred. I'm a trainer and consultant for Angular. I'm focusing on Angular in the enterprise. And in this role, I'm doing a lot of consulting and trainings and reviews, as discussed before. I'm also connected to the Angular community. I live in Austria. I do a lot of stuff in Germany, and I'm always happy to work together with people around the globe. Okay, so let's get started with forensic analysis. And by the way, one thing that is better than forensic analysis, it's a bit off topic, but I have to mention it. There will be 2 new Dexter shows. Perhaps you've seen it. I'm a big Dexter fan. There will be a prequel and a new, completely new show. And yeah, I'm really looking forward to this kind of forensics. But also our kind of forensics is quite nice. What you see here is the first analysis, a hotspot analysis. And this graphic comes from Thornhill's application, his commercial application that is really powerful. We will look into it a bit later again. And it shows your code files and which of them are so-called hotspots. Each file that is red is a hotspot, something that might be dangerous. And it's also orchestrated a bit on an architectural level. We see here packages and so on. So what is a hotspot? Well, a hotspot is a file with a high code churn. However, somehow you need to prioritize all those files. And this is where complexity metrics come in. That means you are using a very strong metric like changes, code churn, and use a weaker metric for its prioritization because you cannot look at everything at once. So you need to find out, well, let's start with this and then let's proceed with that. This is somehow nice because suddenly those metrics are put into a context. And another important aspect here is we have to think about a good time frame. Usually we don't do it for all the log entries. Usually we do it for, let's say, the last release or the last releases, or perhaps there was some situation, a big incident, and we tried to improve our quality since then, and then we would look at this very time frame. So thinking about a good time frame is vital here. And the tool I'm using here is Thornhill's tool, which is called Code Scene. Really, really awesome and nice visualizations. Okay, so it's basically...
Is that tooling language specific, or does it support multiple language, or...
Yeah, that's the good about this one. It's language agnostic, or at least it supports a lot of languages. He's doing a lot of stuff with TypeScript, but also with Java and .NET.
Okay.
And yeah, so all the major languages should be covered there. So what does a hotspot tell us? Well, too many responsibilities. We just discussed this before. The so-called God class, a class that is doing too much. Or perhaps we don't have a clear modularization. Perhaps we should rethink it. Or perhaps we have an error-prone implementation, and so we need to fix it time and again. Or we have too little domain knowledge, so we need to implement everything little by little when we become aware of this or that requirement. And I think in general, the important mindset here is a hotspot is not necessarily something bad, but it's an indicator. It allows me to ask a question to myself or to my customers. There is another nice technique I have here. It's change coupling. This is not a dependency graph. It's more about which things have been changed together. And here we see the two domains have changed together a lot. Here we have quite a thick connection, which means here in this graphic, they have changed a lot together, those features. And yeah, so this is hidden coupling. Perhaps there is no direct connection. And for this here, I use Detective, which is my open source take on this. So possible reasons, one more time, too many responsibilities or no clear responsibilities, no clear modularization, or perhaps code duplication. We have duplicated our code, and so every time we change this here, we also need to change its counterpart, because otherwise we would get, inconsistencies and so on. Currently in Angular, we have two if implementations. It would be interesting to look at this. On the other side, I assume that the if is quite stable, that we don't discover that many new requirements for an if and an for. So perhaps change coupling is not what is unveiling this relationship in Angular. Or domain understanding. One last thing, and this is really where we go full cycle now, Conway's law and team alignment. So if we have the situation that the teams are working with other verticals a lot, then we might have an issue. And this is something we can find out with a team code alignment analysis, where we just look at all the commits and look at which files from which verticals have been committed together, or perhaps we have several commits coming from the same feature branch, or perhaps we have some commits that point to the same Jira ticket ID. And in this case, this might be an indicator that we work against Conway's law, or that developers ignore the official team structure. I had this situation, a very complex system, several teams, several business domains, several years of development. It was quite a complex area. But the UI was quite simple. They just had a handful UI developers. Most of the complexity was in the backend, calculating stuff that needed to align with changing laws and so on. And because they learned about Conway's law, they took those, let's say, 5 front-end developers and put them into different teams. However, for most of the time, those 5 front-end developers were sitting next to each other. And of course, they were communicating a lot with each other, because there were the only 5 front-end people in this team. And so they had some kind of shadow structure, some kind of shadow organization. And of course, this influences stuff like this here. And I don't necessarily say that this is bad, because Conway's law is not the law of nature. But one more time, this is something we should think about, something we should at least discuss, bring to the table. And if there is the deliberate decision, well, that's okay as it is, and we really want to do it that way, then it's fine.
Yeah, that's one thing I always try and drive home to people in helping them, is like, get all the answers, think about all the things, all the scenarios, bring them all to the table, and then just be intentful about the decision and the trade-offs that you make. But as long as you have all the information, you can make an informative decision and be confident about what you're going with, right? It's collecting that information that's key. What's so fascinating about this is that it starts to reveal these other things that you don't even really kind of think about, or how do you quantify and picture that? And now this is surfacing, going, like that whole one you just talked about with the relationship and saying, oh, well, these two things change often together. Like I may have not even known that by just the processes we have in place, but now it's a new thing that piece of information, clue that I can look at to make a decision off of, right?
Yeah, totally. Making it visible is the key here, I guess.
Yeah,
and talking about it, like you said, having those discussions about it, right?
Mm-hmm.
And what you're doing there is something that a lot of systems have done throughout the history of time is you have all of this information, or excuse me, this data sitting there of all these different data points of a whole lot of information that may or may not be correlated. And you're turning that data, that raw data, into the information to see these correlations and how they associate with each other, especially over time.
Mm-hmm. Yeah, so it's already there. We just have to analyze it. Yeah.
But that brings up an interesting thing that I've been thinking about is when a system is in its infancy, as it's growing and trying to get its structure and everything else, is there a certain level that you expect a system to be at before you can apply these principles? Because as I'm putting together a system, I'm one of those people who doesn't refactor until I need to. I'll put everything in a component before I need to move it out to a service, and even at like the system level beyond that, but just start all local and refactor out as needed. So there's going to be a lot of volatility with that before you create a utility library or some sort of like common piece that everything else is based on. And these verticals may not even exist early on. So I'm curious what level you expect a system to be at before you can apply some of these principles.
Yeah, so I feel you, and I do it quite the same. So when I start implementing something, I write it down and then I improve it at a later point in time. This also prevents me from doing wrong abstractions, because sometimes if we go with a wrong abstraction, it's even worse. It adds more cognitive load if we have to think through 7 components that don't make sense. There is some evidence that code churn is more critical when the project has stabilized, and that it is more natural to have a higher code churn in the beginning. But at some point in time, your architecture will stabilize and so on. I also think it's one more time about doing a deliberate decision. If you say, well, this is our way of working, now the first goal is a version 1.0 or an MVP, and then we make it pretty. When we get the right funding, then it's fine. But I think this is something you should clearly define. It should not happen by accident. Okay, cool. Yeah, tools. Let's talk tools. CodeScene, yeah, very cool tool. It's from Mr. Adam Dornhill himself, and it's free for open source projects, but commercial for commercial projects. And it has a lot of analysis methods, really a lot of them, nice visualizations, and supports several programming languages. By the way, I think it not only supports Git, but also other stuff like SVN. And it works on a code level and on an architecture level. That means that the findings on the code level are aggregated to your modules. You define where your modules are, your verticals, your domains, and then it's aggregated on an architectural level or on a team level, if we talk about a team code analysis. And then this is the hyperlink. Then here, this is my turn. We call it detective, and it's open source. It's limited to a few methods. It's only on an architectural level, more or less, and it targets TypeScript. And here we want to use it for reviews to just come up with 3-4 better questions. So it's not about replacing our process with it. It's about finding some additional good questions to discuss. And as the effort of this is quite low, I think the gain can be quite high. And yeah, I see it as an appetizer for CodeScene. So all the credits go in the direction of Adam Dornhill, who invented this new kind of analysis, or at least eventualized it a lot. Yeah. And my demonstration will also use detective. By the way, this is how you can use it. npm install it as a dev dependency, and then you run nbx detective, and yeah, then you already see what's going on in your application. So one last thing, limitations.
Real quick. So the detective is your tool, correct?
Yeah, this is mine.
Does it take arguments of so you can specify either like a commit hash or a date to say, hey, I'm only interested in looking at this and the connections in the last 6 months, 2 releases, whatever.
Yeah, so currently we can limit it by commits, just take the last 1,000 commits, or by time in terms of month.
Okay.
So perhaps we implement some further filters, but this is what we currently have.
Perfect. Thanks.
Very welcome. Okay, limitations, because no silver bullets here. So this was our process we started in the beginning with. And all of the stuff we have discussed here might be awesome, but it's not a replacement for all the other stuff we discussed in the beginning. However, and this really helps my monk within, it can be a nice addition. And
Nice.
forensic analysis or some other kinds of analysis can be a nice addition. It basically helps us to ask better questions. And yeah, so we get hopefully better results. But it would be a bit too easy to just run a tool to get 7 numbers, and this is the result of your whole analysis. This reminds me a bit on CEO audits, where you get such a reports with all the stuff you could do in theory. It does not help that much. Okay, so conclusion. Metrics, take them with a grain of salt. Metrics should not become a target. Think about code coverage. Low coupling, high cohesion, and Conway's law is what we are looking for through our architectural classes. Hotspots are regions with a high change rate and a high complexity. Complexity metrics are not perfect, but here we use them to prioritize stuff with a high code churn. We have change coupling, stuff that changes together, and theme code alignment. What do we have else? Yeah, it's not a replacement for all the other stuff, but a nice addition. And yeah, so everyone who is now interested should really try it out in their very own application. Just run those 2 commands and give us some feedback here. And I think now it's demo time, or do we have any questions?
Yes, really quick. So if I have a mono repo with like 1,000 libs in it and I run the detective on it, what am I expecting? A lot of information to come back?
First of all, we had the impression that there might be issues with really large scale mono repositories. But then we discovered that those repositories had some links in there, and this was the issue, symbolic links and so on. So now we have another implementation for looking at your mono repo, and now it looks like even with huge mono repositories, it works quite well. We need to investigate some special things like Git large file support. This might be something we need to implement in our Git parser. And there was something else. I think it was also symbolic links in there or stuff like this that may cause issues. Yeah. Or may cause an infinite recursion.
Yeah.
But usually we are quite good. I used some project of mine for testing, some projects of my colleagues, and the Angular repository, which also is also quite a huge repository with a large amount of commits since 2015 or 2016.
Does your tool account for tests? Does it ignore test files or allow for a potentially exclusion of the test because something may look more used or more complex because of tests than it would without?
Yeah, that's a good point. So when we look into the Angular repository, spec files are always in the top 10 of the most complex files. And yeah, meanwhile, we can exclude them because sometimes we don't care about spec files. Sometimes we do, because if each and every feature demands a change in hundreds of spec files, then perhaps we should think about our testing strategy. Perhaps then our unit tests are testing too much. This is one concern or one perspective. But on other occasions, it's just annoying if we stumble upon all those spec files time and again. So we can feel that.
So speaking of metrics, a quick question, you may not know this off the top of your head. Running your detective tool against the Angular repository, how long does that take to run?
Well, it's pretty fast. I was really astonished. It's pretty fast. The only thing that is slow is running git log, because Git is collecting all this data. But
Right.
once you have it cached in a text file, it's really pretty fast.
Okay.
I really had to smile because when implementing all this stuff, I thought about, well, here I should do a bit better in terms of performance. Here I could get rid of the loop, but as it turned out, it did not matter that much. As soon as we have the git log in the text file, it's really pretty fast. And that's why we are caching your git log.
That makes sense. So if I were to ask you how long it took, what unit would you use? Seconds, minutes, or hours?
Well, to fill the cache in the case of the Angular repository, I think it's 16 seconds. So the first time you start it 16 seconds, but then it's really fast and you can click around and you see immediately.
That's awesome.
Cool. Okay, so let's try this out. So here I'm in my example application. I'm calling detective, npx detective. And yeah, this is a very simple overview of my two domains, of my two verticals, ticketing and check-in. It's one more time about flights because this is my usual example. And both is using a lot of stuff from the shared area. So we can move this around, which is a lot of fun, and we can break it down to the next level. So what I'm doing here is I'm following the recommendations of the NX team in terms of structuring the application in scopes, or I call it domains, check-in ticketing, and into layers, like we have a feature layer with two feature modules, or a UI layer with general purpose UI stuff, dump components, and a data access layer. And yeah, at first glance, this really looks like what the NX team is telling us and what we also do in a lot of projects. Sometimes this is just a folder. Sometimes those verticals are NX libraries. Sometimes they are micro frontends. But more or less, this is the DNA of what we do quite a lot. But if we look a bit closer at this, which is not a forensic analysis, so far it's really just about visualizing dependencies. If we look a bit closer at this, we see that one feature is accessing another feature. And this might be okayish, but I would at least want to discuss it. Because if feature A is allowed to access feature B can access feature A, and then you have a cycle. So sometimes we don't allow this by terms of linting, and sometimes we say, well, we know what we are doing, let's go. But this would be a first thing I would ask a question about.
But that points to the power of the tool that you have here is, as part of your architectural reviews and looking at this, it's not so much like, hey, this is wrong because our tooling said it's wrong. The tooling is saying, hey, look at this and then make a decision. And it's giving you ideas of where to look at it. A drug hunting dog is just going to say, hey, you may want to look in this bag. Not that there is something wrong in this bag, but just, hey, something kind of smells in here.
That's really an awesome metaphor, yeah? I think I will borrow this metaphor. I like it.
No problem.
That's exactly what it is, yeah? Okay, so let's start with forensics. Let's start with change coupling. At first glance, it looks like a mess because a lot of those modules have been changed together. But of course, we should limit the time frame a bit. Perhaps we should just look at the last year or the previous 6 months, or perhaps we should filter by connections. Perhaps I'm just saying I'm only interested to it when there have been at least 4 changes. And now if I group it by folder, then I see that my domains are not as decoupled as we might think. Of course, from a dependency perspective, they are super decoupled. But from a change coupling perspective, we see that quite often this guy and that guy is changing together. And one more time, this raises a question: is this good or bad? Should we do something about it? And there is some more data if we click here on it. So we see 4 connections, which means there are 4 commits where we have changed both together, this feature and that feature. And here we see 6 commits. So that means in 4 of those 6 commits, we have changed those 2 guys together, which is quite a high change coupling.
Now, is this file changes, like actual like code changes together? Because I think there's also that concept of like, I changed this shared and it resulted in the build out artifact of each of these needing to change, even though their code doesn't have to change. But because they're using this thing, I had to rebuild them and re-release them.
Yeah.
Is there a concept of that too, or is it just file changes?
Yeah, so this was really something I wrapped my head around when implementing this, because it sounds that easy. It has been changed together, but what does it exactly mean? And let's do this away. My finding there was, and it kind of makes sense, that if you have a commit that is changing, let's say, vertically 1A, vertically 1B, vertically 1C, vertically 2A, then you just take those 3 entries as one entry. You just say vertically 1 has changed together in this commit with vertically 2. You don't say it has been changed 3 times together with this vertically. You just want to know on this architectural level that one feature demanded to change this here and that here.
And I imagine that it would be too complex to worry about different chunks within a file, that the association, whether changed together, is based off of commit and file and not any finer grain detail beyond that.
Yeah, that's actually a good point. So currently I don't have this. I think code
I'm not requesting it. I think at file level points well enough. And then through, again, giving you that dog pointer of, hey, you want to look at this versus, hey, we're getting down to the actual code at this level here.
Oh, now I get you. Yeah. So I think we need to implement this sooner or later, because, of course, if you see this connection, the first question is, where do we have those 4 connections?
Yeah.
So I think we need some detail level that shows us, well, this and that file is influenced, and perhaps a link that opens the file in your IDE or something like this.
I think even beyond that is, if there's a way to drill down, so it says 4 connections, if with those connections, if we could get access to the commit hash, then we can go and do our own investigation beyond that.
Yeah, that's also possible. Of course, it's not that convenient if it gives me the commit hash, but yeah, then we can help ourselves. You're right.
That's cool.
Okay, change coupling. So here we have hotspots. Or perhaps let me show you something else that's also interesting. And it shows why usually it's not the best idea to mainly structure your application with respect to technical layers. Because it's quite natural that different technical layers of your solution change together. So let's say you have a new field in your database, or you have a new query. I want to read my invoices by the invoicing date. Of course, I need to respect this change here in the data access layer, but also in the feature, and perhaps even a dump component is affected by it. So usually we have a huge change coupling between layers, and that's why it's really good that we are doing something in the Angular community now since, I think, more than 7 years. We mainly structure according to features or to business domains, according to, let's call it, functionality. Okay, hotspots. So what we have here is an aggregation on the component level. Perhaps we do it that way. So we see that we have here several hotspots in ticketing, 19 hotspots. And here we see how the hotspot is calculated. We see per file the amount of commits, the complexity, and then the product of both. We just multiply it. And this is just a SWOT index. This hotspot score is just a SWOT index. So it does not make sense to tell in kindergarten, well, my daddy has a hotspot score of 1,000. Oh, it's nothing. My daddy has a hotspot score of 5,000. This does not make sense. It just makes sense as a SWOT index in this very result here. And yeah, so usually what they say is start with the highest third. So if the highest score is 200 or 220, then we should do the math divided by 3. And then we should look at the highest 70, 80, which is 219 minus this, and the other way around. And yeah, then we look at the upper third. We start with this. We investigate this, we question it. And yeah, then we are going on perhaps with the middle third. And yeah, obviously it does not need to be an issue, a high hotspot score, but one more time, it's an indicator. In the Angular repository, by the way, the highest hotspot score beyond spec files is the Angular compiler itself. And I think this makes a lot of sense because I think without thinking a lot, most people would say, well, this is a very complex piece of software there. Team alignment. So here we see everything is done by the alpha team. Let's break it down to the user level. It's me. So here we see who is doing all the hard work. No, just kidding. It's a demonstration repository. But to make it a bit more exciting, I have here demonstration mode, which is squeezing in some additional users like John Doe and Jane Doe and the German John Doe, who is Max Muster or Max Mustermann, and of course, my lesser self. And I also group them to teams. So this is done in the configuration file. Currently, we don't have a form for it, but in the configuration file, you can just say, well, this team consists of those GitHub users or Git users in general, and the beta team consists of that Git users. And yeah, so if we look at this here on a team level, the alpha team, the beta team, the gamma team, then we see that we perhaps can do a better job in terms of team alignment, because it's quite mixed up, isn't it? Well, perhaps this is just a possibility. Perhaps there was just a gamma team in the beginning, and now the beta team starts taking over responsibility for the ticketing domain. To find this out, we need to limit the time frame a bit, which does not make sense here because it's a demonstration project. Or perhaps we have a shadow structure in terms of team alignment. Another interesting thing here is if you look at the user level, you see the drag factor. You see how many people can leave the team until you have a serious issue. And yeah, in this case, if Max Muster is leaving the check-in team or the company, then the check-in domain has an issue because he knows by large most about it.
This is
So
really fascinating. Like it's awesome data to be able to see and quantify, right? Like I might just think about it in terms of going, okay, well, I have this feeling about these devs and this team and how often they're putting up commits or PRs that are touching this other code, right? I just have a sense of it, but I have no like measurement of it or no visibility of it. And this I can quickly see, you know, oh, okay, over this time, this is where they actually were making code changes over here. And do we have our structure right? Do we have our patterns right? You know, to enable them to really be focused on their domain. And this is, I'm anxious to use it.
Yeah, and I'm also looking at it from not just the check-in level on the domain level. Can you expand the on the tree on the left, check-in and see, maybe check some of the items underneath?
yeah, totally. I can.
Yeah, just that right there. To say, all right, yeah, now Max is really big on the check-in data, and we may be closer to okay with the feature manage, but the check-in data is really where hey, Max had some stuff going on outside the office, not so much some technical issues, but some personal things that we need to get rid of them. So where do we need to focus the training and the co-education within that?
Totally, yeah.
Or even just identifying areas that we need to disperse knowledge.
Disperse, yeah.
And another idea is to define an artificial X-team member team. Let's say, I don't know, the green team is the X-team member team. Then you see which knowledge you already lost because of a lot of people leaving last month. Yeah, after the Christmas party.
That's cool.
Awesome. Yeah, that's it more or less. So one more time, give it a try, provide some feedback. We will do some UI, basically UX improvements in the next months. And yeah, give us your feedback. And we are, of course, interested into situations where there is an issue. Perhaps we did not foresee a specific constellation in your Git log. As mentioned before, Git large file support is something we definitely have to look into, but give us also other hints and give us your success stories, of course. I'm always interested into how useful it was and where the pain points are.
Just a personal query here. What charting utility are you using for all your visuals?
Yeah, that's good. Most of the time went into evaluating those tools, especially tools for graph
I was really curious about this one.
And also the right settings to make this graph not too much overlapping. And I cannot pronounce it, but I can show it to you. It's an X. Front and backend, front end feature. It's actually a dump component. Where is it? Graph. Raw graph in there. Yeah. So this is the guy I'm using. And yeah, after trying out a lot of stuff, together with ChatGPT, I landed here with this guy. And yeah, it comes with several layout strategies. It was about a bit trial and error. The other stuff is rendered with chart.js. The donut chart is just chart.js.
I like it.
Nice.
Sure. Okay, yeah, that's all I have for today.
Awesome.
Yeah,
Awesome. Well, that was pretty amazing. Yeah, I'm excited to start using some of this stuff and check it out and get some new learnings for sure.
Awesome.
Do we want to do some quick picks? Mike, do you have any picks?
I don't have any picks this week.
All right. I'm going to pick one. I'll pick a couple of things. I'll pick a couple shows. First, I'll pick The Penguin. That was, one episode so far. It's pretty amazing. Cinematography is pretty amazing. The storytelling is cool. I like it a lot, so I'm excited about that. And then the other one, based on our forensic stuff and investigation stuff, there's a show that my wife and I watch called Expedition X, and it's this crew that kind of goes out and investigates like paranormal stuff or like things like the Loch Ness monster or things like that.
Oh, wow.
It's kind of a fun little thing, but they do these investigations. They use all kinds of like hardware and stuff to try and monitor spectral things. And so it's pretty fun. So I'll pick that because we're doing an investigation show.
Speaking of shows, Manfred, did you mention that there were 2 new Dexter shows or just the prequel show?
Yeah, there are 2 new Dexter shows. The first is a thing called First Sin. It's a prequel.
Yeah.
But there is another show in production. I think they will air it next year. Dexter First Sin airs in December, but
Okay.
the other one airs next year. It's called Resurrection. Resurrection. And the original character is in there. So people are speculating how he can be in there because he was kind of dead last time we saw him. So yeah, there are a lot of speculations on the internet how this can work.
Excellent. I had only heard about the prequel, so thanks for the info.
There we go. All right, Manfred, you got anything else that you want to pick or plug or anything before we wrap up?
Well, yeah, as mentioned, try out Detective, give some feedback, and yeah, that's it, I guess.
All right. Well, hey, as always, we really appreciate you sharing your time and coming on with us and educating us and showing us new stuff. We really, really appreciate it.
Yeah, thanks for having me. I really like this format. It's really cool.
Nice.
I love
We'll
today's
see
show.
you again for sure. Huh?
See ya.
All right. Take care.
Take care.